Today we're doing pages 135 and 136. Psalms 149:4 says, "For the Lord takes delight in his people, he crowns the humble with salvation." Now, we've been learning a lot about how to reduce fractions, and I'll put a fraction up here as an example. For example, if we had 4/8, and I said, make sure you reduce your fractions, well, you'd think of your GCF, your greatest common factor. And your GCF for 4 and 8 would be 4, because 4 goes into both 4 and 4 goes into both 8. And so if you were to reduce 4/8, you'd say 4 goes into 4 one time, and 4 goes into 8 two times. Now these would equal each other. When you reduce fractions, they equal. They do equal each other. What I mean by that is, I'm going to draw a fraction here, and I'll make 4/8. So if I was to divide this into 8 parts, now let's say I did that evenly, and you were to fill 4 out of the 8 parts, it'd look like this. 4 out of the 8 parts would be filled, and I'll do the same down here for 1/2. If I were to divide it in half and fill it, even though I made these very sloppy, these would equal each other if I could draw them well. And so we're going to look at today more about equivalent fractions, fractions that equal each other. And they're kind of showing the same thing here, where we have 1/2 and 4/8. All of those equal each other, along with 2/4, 8/16. They're all the same thing. They're just written differently. And it's telling us the rule says an equivalent fraction can be found by multiplying the numerator and the denominator by the same number. And so what they've done here is taken 1/2 and they multiply it by 2. Well, 1 times 2 would be 2, and 2 times 2 would be 4. And so, as long as you multiply the top number and the bottom number by the same, you're going to get an equal fraction, an equivalent fraction. We're going to go ahead and get started in class practice number 1. And it tells us to write equal for equivalent fractions and not equal for unequivalent fractions. So here what they're asking, they're saying, does 3/8 equal 6/16? Do they equal each other? Well, 3 times 2 is 6, and then 8 times 2 is 16. So these do equal, and we need to draw an equal sign. Let's look at B. 4 times what equals 8? 4 times 2 would equal 8. Alright. 7 times 2 would equal, well, not 21, it'd be 14. So this is not an equivalent fraction. So we need to draw the equal sign with a line through it like that. Okay. 3 times what will equal the 6? 3 times 2 will equal 6. So then we need to do 4 times 2. And does that equal 12? No, it doesn't. So this again is an unequivalent fraction. Okay, D. 2 times what equals 4? 2 times 2 equals 4. So now let's multiply the bottom number by 2 also. 5 times 2, does it equal 10? Yes. So this one is equivalent fractions. So for number 2, they're asking us to write an equivalent fraction for each. So we need to write an equivalent fraction for 2/3. So what we could do is multiply both the top number and our bottom number by, I'm going to do by 2. 2 times 2 is 4. And 2 times 3 is 6. And so that's an equivalent fraction right there that we can use. Now let's not do 2 every time. Let's do 3 this time. We're doing the top number in B times 3. 4 times 3 is 12. And now we'll do the bottom number times 3. 5 times 3 is 15. Our answer is 12/15. Alright, we did 2, we did 3. Let's do 4 this time. 3 times 4, I'm doing the top number. 3 times 4 is 12. And 7 times 4 is 28. And so that is a fraction that is equal. Just like here we have numbers that are different, but they all equal when you look at the pictures. They all equal. They're just cut differently. Alright, D, we got 2 over 9. Let's multiply it by 2. 2 times 2 is 4. And 9 times 2 is 18. We get 4/18. Okay, number 3. The directions tell us to write the number that should be put in place of the x to make the fraction equivalent. First, decide what number was used to multiply the denominator by to get the new denominator. So what they're saying is, okay, let's see, 3 times what equals 6? Well, 3 times 2 is 6, so we need to do 1 times 2. Whatever you do to the bottom, you do to the top, and they've shown the work there for that. Alright, 5 times what equals 20? 5 times 4 is 20. So times 4, I'm going to do times 4 up here also. If 5 times 4 is 20, then I need to do 4 times 4 on the top, and 4 times 4 would be 16. Okay? 5 times what would equal 15? 5 times 3 equals 15. So I need to do 3 times 3. Whatever I do to the bottom, I do to the top. 3 times 3 is 9. 2 times what is 8? 2 times 4 is 8. So if I do times 4 there, I got to do times 4 at the top. 1 times 4 is 4. Last one for this side. 4 times what equals 12? 4 times 3. So if I do a times 3 there, I got to do a times 3 on the top. 1 times 3 is 3. Go ahead and look at the back side. We're going to look at number 6. Before we do that, well, let's go ahead and do 6. 6 tells us to reduce. We have 4 over 8. What goes into both 4 and 8? 4 does. 4 is the highest number that goes into both 4 and 8. 4 goes into 4 one time. 4 goes into 8 two times. We get 1 over 2. Okay, what's the highest number that goes into 3 and 15? 3 is the highest number. 3 goes into 3 one time. 3 goes into 15 5 times. 9 over 12. What's the highest number that goes into 9 and 12? 3 is. 3 goes into 9 3 times. 3 goes into 12 4 times. D, we have 5 over 15. What goes into both 5 and 15? 5 does. 5 goes into 5 one time. 5 goes into 15 3 times. Number 7, it says change to a mixed number, reduce if necessary. So we got to divide our bottom number into the top number. We got to say how many times does 4 go into 5? 4 goes into 5 one time. And when you subtract, you get 1 left over. So it's 1 and 1 over 4. 1 and 1/4. Okay, 9 goes into 17. I'm going to do it in my head here. One time with 8 left over. And 9 would be your bottom number. 1 and 8 ninths. 6 goes into 8 one time with 2 left over. And you keep your 6. Now, it told us to reduce if necessary. This one can be reduced. It becomes 1 and 1/3. Because 2 goes into both 2 and 2 goes into 6. Go ahead and do D on your own. On number 8, it's kind of like what we did on the other side. 5 times what equals 20? 5 times 4 equals 20. So you need to do times 4 right there also. 4 times 4 would be 16. 8 times what equals 32? 8 times 4. So if you do times 4, you got to do times 4 here also, and you get 28. Okay, number 9 tells us to write grams or kilograms for the weight. Thumbtacks? Oh, that'd be grams. Candy bar? You'd measure that with grams. A large dog? That could be kilograms. A person? Same thing. Kilograms. Computers? Kilograms. A letter? Well, that'd be measured with grams. You're going to go ahead and do the rest on your own. I'm going to help you, though, and tell you a little bit about a tidal wave. Now, you guys have probably heard of what a tidal wave is. It'd be a giant wave. And it might be coming in on the coastline of land. And it'd be huge. It'd be scary. They'd evacuate the area. We hear the test sounds. They test the bells every the beginning of the month. And it's those horns that go off. But if a real one happened, we'd get away from the coastlines, anywhere near water. We'd get away. And our school is right above the tsunami warning line. We're a safe place at our school. We could probably go outside and watch it if it were to happen. And what would be really interesting is, before it happens, before the tsunami comes, the water recedes. You see a picture here of water receding. It looks like originally the water went up to here. But right before a tsunami is going to hit, before a tidal wave is going to hit, the water pulls away. And it'll go all the way out to the horizon. And if a person were foolish enough to do so, he or she, they could walk out several miles before the wave came smashing onto the shore. So hopefully that helps you to get your math done. You guys are so smart. You guys are so smart. You guys are so smart. You guys are so smart, so math smart.